Hello, everyone, and a very warm welcome to today's webinar, Winning the AI-powered GIS Race, How to Differentiate Your Platform in 2026 and Beyond. I'm Rohina Chawla, your host for today's session, and it's a pleasure to have you all with us today. Before we begin, a few quick notes. We'll be sharing the webinar recording after the session. For the best experience, we recommend using headphones. Lastly, if you have any questions during the session, please post them in the Q&A window. We'll take them up towards the end. A short, context of the session. The GIS industry is evolving rapidly with AI, automation, and cloud technologies redefining what customers expect from modern platforms. Today's webinar will explore how GIS companies can stay ahead by embedding AI, modernizing legacy systems, accelerating innovation, and expanding into new industry opportunities. Leading today's discussion are two senior leaders at Amantya who have been closely involved in Amantya's GIS initiatives. I will quickly introduce them before we begin the session. First, we have Lakshay Khattar, Manager Business Development at Amantya, who works closely with organizations to drive growth through technology transformation and strategic GIS initiatives. Joining him is Vipin Sharma, Technical Lead at Amantya, who brings deep expertise in GIS engineering, platform modernization, and enterprise geospatial solutions. Welcome, Vipin and Lakshay. Over to you, Lakshay.
Good evening, everyone. Thank you for joining us tonight. I want to start with one idea that is reshaping every GIS platform in the world right now. GIS is moving from helping organizations see the world to helping them act on it. And this shift is no longer at the edge of the industry, it is at the center of it. The platforms winning enterprise deals today are not the ones with the best maps. They are the ones embedded in how decisions are actually made. My name is Lakshay. I am Business Development Manager at Amantya Technologies. Over the next few minutes, I'm going to set a strategic context, what has fundamentally changed, where most platforms are genuinely falling short, and what the path forward looks like. After that, I'll hand over to Vipin, our technical lead for AI and GIS. Next slide, please. So, giving a snapshot of the agenda, I'll be talking about oh, the corporate snapshot, who we are, why we are the right people to have this conversation with. We are built on real engineering, not just consulting. The world has changed. GIS is no longer just maps. It is the backbone of real-time operational decisions across every major industry. The AI readiness gap in GIS platforms. Most platforms claim AI. Very few actually deliver it in productions. Here's what that gaps look like and why it keeps happening. How has AI ready GIS platform actually doing? It's just not demos, not the features, what it means when AI is generally embedded into the product and how it looks like. What is the real bottleneck? Why Amantya? And how we'll help you to succeed from the integrations that we do with our AI powered platform. Next slide, please. Here. Before we get into the GIS landscape, let me take 2 minutes to establish who we are. Because what you're about to hear comes from building, not from advising. Amantya Technologies is a global product engineering company. We were founded in 2018 with a handful of people and now have grown up to 1,000 plus engineers across India, US, UK, and Canada. We deliver AI driven cloud native platforms across 15 plus countries and 9 industries. So, from past 2 years, we have shifted our focus into delivering AI enabled product engineering and digital transformation using industry leading technologies, keeping our focus onto these 4 technical areas, which is AI and data, cloud and digital, communication, and connected devices. We have vast engineering strength in various technologies from embedded hardware, 5G telecom, and AI full stack, cloud, and DevOps. Next slide, please. If we look what's happening across industries right now, telecom, utilities, logistics, smart cities, the numbers tell a clear story. Geo market growth, Geo AI market growth is increasing rapidly. It has almost doubled. It is expected to be double by 2030, and this is the demand is rising because of the AI driven spatial analytics across various industries. Approximately 30% of AI integrated geospatial analytics can boost operational efficiency. We have also seen that real time analytics brings the return of around 13.1% CAGR, which the organizations focus on. And currently, the organizations are heavily investing in AI, but they are not fully realizing its value. And GIS sits right at the center of this problem. Let's take an honest look where most of GIS platforms stand today. Because despite all the progress, all the announcements, all the AI demos, there's still a significant gap between the GIS platform promise and what they actually deliver in production. So the problems they currently face are the AI exists, but it is not in workflows. Data preparation is still manual. There is no end to end pipeline. Real time intelligence is still missing. Domain intelligence is too generic. The POC to production gap is there, but when it goes live at scale, it breaks down or gets abandoned. So the issue is not a lack of technology, it is lack of integration, architecture, and operational readiness. So the current six structural shifts that actually have changed the landscape are as you can see below. So shift one talks about how the GIS world was used only to show the maps on the world and how it actually looked, the maps looked. But now it actually has to actually run it. The original purpose of GIS was to help you see that era is over. GIS is now expected to drive decision, not just display them. Basically, a logistic company isn't looking to route on a map. It's rerouting its fleet in real time based on live traffic and delivery windows. A utility isn't mapping its assets. It's predicting which transformer is going to fail build before the outage happens. GIS is no longer a picture of your world. It is the system through which your world is actually managed. Earlier, the GIS was only used by the specialists, and now it is used by everyone. People who never ran a spatial query in their careers are also using GIS platforms. If your platform still requires a specialist to unlock its value, you're not a modern GIS platform. You're a legacy tool with a modern logo. GIS is used to work on last night's data. Now it has to work right now. So that model where where you were working on the last night's data is dead. Hence, grid traffic management now adopts in seconds. Grid monitoring flags anomalies in milliseconds. Disaster response maps reflect ground conditions as they change, not after field teams have their field reports. GIS is used to serve, earlier GIS was used to serve only one industry. Now it is serving many industries together. The same platform is now expected to serve the utilities, telecom, smart cities, agriculture, and real estate, each with fundamentally different data models and decision logic. Generic AI does not survive contact with domain reality. It now only it works until it has production. GIS is used to need GIS used to need an analyst for everything. Now AI should be doing the heavy lifting. So this shift has recently come up in the past 2 years where 88% of the organizations are already using AI, but only a third are scaling it across the enterprise. In GIS, specifically feature extraction, change detection, predictive modeling, these should no longer require analysts sitting in front of a screen. for hours. Instead a- of a team spending 2 days identifying damage in satellite imagery after a storm, AI does it in minutes. Every hour your team spends manually clearing geodata is an hour a computer spends on strategy. AI adoption is real, but AI maturity is still rare. GIS used to live in its own world, now it has to connect with everything. Earlier, GIS used to work as a separate tool in its own, doing the things that it was required to do. But now, organization expect it to integrate with your ERP, CRM, or OSS because unless if the GIS cannot talk to all of that in real time, cleanly, bidirectionally, it becomes a reporting sites show. GIS is no longer just a tool, it is becoming the operating system for spatial decision making. Most platforms have adopted to one or two of these shifts. Very few have adopted to all six. The platforms that don't adapt would just fall behind. Recognizing these shifts is one thing, knowing where the platform shift sits against each of them and knowing what to do about it, that is differently conversation entirely. And here's the single biggest reason those transitions stall. It is not the models, it is not the compute, it is not the talent, it is the data, the pipeline, the foundational infrastructure that AI needs to actually function in production. And this is where exactly Vipin comes in. Vipin is a technical lead for AI and GIS at Amantya. He's going to take you through AI powered GIS architecture. Vipin, the floor is yours.
Hi everyone, good evening. So let's move to the most important question. Right? If AI is already being adopted across industries, then why most of GIS platforms are still not truly AI ready? So the reality is the gap is not about awareness, it's about how AI is actually being used inside GIS platforms. So in most of cases, like AI is added on top of it, not built in that into the system. For example, feature extractions may exist, but it is not connected to entire workflows like asset management or network operations where real decisions are happening. Another major issue is data. Spatial data still comes from multiple sources like shapefile, CAD file, satellites, and different IoT devices. So, and there is a huge team who spends a huge amount of time just to preparing it. There is a there is also no continuous pipeline, like data moves manually from field systems to the GIS, then to the AI models, and then the actual data source to the dashboards, which breaks the actual scalability. In real time intelligence is still missing. Many platforms are still working on the batch files while operations are require live insights. And finally, AI models often ignore domain context. Like a model which is trained for urban imagery may fail completely for utility networks. So, for all of this concept, as we were looking for that how most of GI systems fails and how we will proceed, what steps we will going to take moving further to succeed in the current market. So overall, the platform is still not AI itself. It's the AI is not deeply integrated into GIS workflows. Okay, moving to the next slide. So here, what does a truly AI-ready GIS platforms look like? On the left-hand side, we can see the table stacks where most of the existing GIS platforms do everything. Automated object detections, land cover classifications, change detection across time series, manual or rule-based infrastructure, predictive modeling, demand forecasting. So all of these is already done by the existing systems. But what make the differentiator? On the right hand side, we can see the differentiator where the actual race is won, where actual AI agents comes in the picture, which is embedded inside the workflows and fulfilling a purpose. So we are talking about conversational GIS, where a normal user can simply type prompt in any language, and system is capable enough to provide the right content or can perform the right actions. Same, the agent is built in to fulfill the multiple steps solution, where an AI agent can itself define the new routes following all the topology rules. And the next and major AI assisted infrastructure planning, where actual agent can design entire area for any kind of utilities. If a user visit to the application and define a particular area, select the utilities like gas, water, fiber planning, whatever user selects, it decide what components need to be picked based on the utilities and design the entire area in just simple prompting. So these agents actually help the applications to work seamlessly and reduce the time and effort. The next and important one is anomaly detection, where actual system awareness comes in the picture. System detects the failures automatically and take the decisions accordingly. It can inform the required persons, it can take the required actions like creating work orders where a maintenance person will visit at their job and can fulfill the work. Same thing for business, they are taking more simulations and digital twin, and they are planning new ideas in the future. A platform can simulate future scenarios as well. So this is the shift from GIS as a tool to GIS as an intelligence system. But even if we know what the target looks like, most of the organizations still struggle to reach their end goals. And the reason is something very fundamental. Let's move to the next slide and I'll showcase you what fundamentals are there. Okay. So behind every GIS tool, there is a major functionality, and the reason of failure is not the algorithms, but it's the data. As data comes from multiple sources like satellites, drones, legacy GIS systems, and enterprise platforms. So all of the data is inconsistent in format, structure, and coordinate system. But because of this, team spends around 50 to 70% of their time to just preparing data before any AI model can ever run. To fix all of this, we actually need to fix this using the automated special pipelines, unified geospatial layers, where all of the data which comes from the different sources are formatted in a unified way. And AI models that understand spatial relationship and continuous model retraining through the MLOps. Based on the user usage and designing patterns, the AI model itself trained to perform the job next time. And without fixing the data pipelines, AI is like AI in GIS cannot scale beyond pilot projects. And this is exactly where we help organizations to move and build the solutions. Okay, moving to the next slide. Why we are here in the market and what problems of the market we have solved. So our strength lies in combining GIS expertise, AI engineering, and real world domain understanding. So combining all of these three can make a actual usable product which fulfill the market problem. By following the multi-domain GIS expertise, we work with multiple domains like telecom and fiber networks, electricity, GIS, land registry, and smart cities. So we work with all of the domains. We have the expertise where we collect the data, we give it to the model and to the till the deployment. We have custom special model training and optimizations. We design the entire AI model and AI agent according to the requirement. So if the industry is looking to integrate the existing AI agent, so we have that AI agent ready. We can embed into their system to fulfill the actual job of the market. From a platform perspective, we build scalable, cloud native, and integration ready architecture. And most important, we are flexible. We integrate with existing systems rather than building it again. So here comes the actual and important point. Instead of rebuilding the entire system, we are scalable enough to integrate the new AI agents and new AI models to the same existing system. It may be the legacy system or a browser system. We don't treat GIS and AI as a separate layer. We bring them together inside our real world workflows. Let me show you how this translates into actual value for organization. We focus on solving the problems in a particle and scalable way. First, we embed AI into the existing GIS platforms without requiring a full rebuild, where a system can be built on top of ArcGIS, QGIS, and with their custom tech stack. We are capable enough to embed this AI native application into their existing platform, which works seamlessly. Again, the second, we fix the special data pipeline because this is the foundation. Third, we help improve AI from proof of concept to the actual production application with continuous learning systems so that they don't become the demo application. They actually fulfill the purpose while they move to the productions. Fourth, we enable extension across domains like utilities, telecom, and smart cities. And finally, we integrate seamlessly with enterprise systems like GIS platforms, SCADA, and ERP, and others. So the goal is simple, make AI practical, scalable, and usable inside GIS platform. And all of this is supported by a strong and flexible technology stack. Right. So the key point here is not the individual tools, it's the flexibility and scalability of the architecture. So we have geospatial platforms, tech stack, cloud GIS and platform engineering, spatial data engineering, and so on. So I will wait for 1 minute and then I'll move to the next slide. Okay, so let's move to the next slide. In the next slide, let me give you the overall context to solving the entire GIS market problem. We have to solve the entire life cycle. So just to fulfill that, the applications should be very easy for the non-tech user, where they can come, they can type the prompts, they can design the actual infrastructure, fulfilling the capabilities of components, how the system will communicate with each other, everything. So to fulfill all of this, we have a demo available where we are showcasing how easy is to build a new infrastructure following all the topology rules. And the same functionalities is not for a single domain, it's for everything, for the entire life cycle and for the entire domains. We are fulfilling all the utilities where a user can come and decide the utilities, and AI agents are capable enough to decide the components according to them, and they can design the entire area. Moving to the next slide, showing you the demo.
Here is our AI-powered chatbot. Users can click on the chatbot icon to open it and start interacting. Let's begin with the first query. Show the best possible path between pit X and pit Y using the shortest route. The system first looks up both pit locations in the database and then calculates the optimal path between them. Currently, it provides two route options, one via main highways and another using a walking path, which may include shortcuts like stairs or river crossings. Now, the user can directly create a component. For example, I'll select cable as the component type. As you can see, the system automatically detects the route and draws the component on the map. Moving to the next query, show path from Konradshöhe, Berlin to Charlottenburg, Berlin. Since these are real-world locations, the system first prompts the user to select the correct locations. Once selected, the route is generated on the map. Now, to create a component in this scenario, I'll select the telco network, and within it choose a sub-location, for example, Sydney. Once selected, the system automatically assigns coordinates and follows the predefined naming conventions. Cable as the component type, and the system automatically connects these points and draws the component on the map. Next query, highlight planned cables in Lura, Australia in green color so I can review them. After selecting the location, the system highlights all planned cables in Lura in green. Next, highlight pits with CM object ID greater than 4513 and less than 4726. The system filters and highlights all matching pits on the map. Next query, show working ducts in Hornsby. After selecting the location, all ducts with operational status are highlighted on the map, as you can see here. Next, highlight all cables whose name starts with C-24X. The system identifies and highlights all cables matching this naming pattern. Finally, highlight cables within 20 kilometers of Sydney in blue. The system first asks for the location coordinates and then highlights all cables within the specified radius in blue.
Right. Thank you, Lakshya and Ripin, for that insightful session. We'll now open the floor for questions. Please post them in the Q&A window and we'll take them up. Okay, I can see a question. You mentioned AI should be embedded into GIS workflows. Can you give a practical example of how that works in real systems? Ripin, can you take that up?
Yeah, thank you, Reena. That's a great question. So in most systems, AI is used separately, like running a model and then manually using the results. Where we are doing is embedding AI directly into the workflows. For example, instead of manually designing a network, a user can simply say that create a cable from A to B, and the system can automatically identify endpoints, generate the best routes following the topology rules, and then create a components. Similarly, user can query special data in natural language or detect anomalies directly with operational dashboards. So AI is not just analyzing, it's helping execute task. Maybe it's all your questions.
So, coming to the next question. How do you connect AI with full GIS lifecycle, not just planning or analysis?
Okay. So that's actually one of the key areas we focus on. So most platforms solve one part actually. either planning or field or operations. But what we have built in connected lifecycle approach. It starts with planning, so where AI helps with routing and designing, then moves to survey. So we have an AI assisted mobile application that helps to survey offline and on the online mode. Once the survey is done, we have the actual plan. Now we correct the plan based on planned versus actual. Once that is done, then the actual execution comes, where work and task are managed. So our inbuilt AI agents detect the work orders, they create the task, they assign to the actual person, and then track that. So that's the actual life cycle we are fulfilling from planning to the actual implementation. Yes.
So I have another question. How does AI help non-technical users in GIS platforms?
Okay. So I think you have seen in the demo video. So as it the AI agent itself become very friendly for the non-technical user, because knowing entire fields and structure of their data set is very difficult for a non-tech person. So these AI agents help replacing all the fields and attributes knowledge to a simple prompt. They can simply type, I just want to see the plant cable on the map. So our agent does not provide the content, they do the actions. So they can see the data on the map. Also, they can create new components fulfilling the topology rules. And this is not for a single domain, this is for entire utilities. So the agents are capable enough to design the entire structure or entire area. So the demo which you have seen, it was just an example of placing a connection between one to one. Now, once user will come and user will decide a particular area, the system will automatically decide components based on the utility and can create the entire plan in a single prompt. And it can provide the cost also, like how much cost will be utilized to design this plan. Yeah.
So we'll pick up the last question for tonight. How do you handle scenarios where AI output needs human validation?
Right. So I think this is a valid question, and most of the persons and organizations are looking for this. In most real systems, AI is not fully autonomous, and that's expected because we can't blindly trust on the AI. But so what we are doing, we are designing workflows where AI provides recommendations. While we design the network, we give the recommendation to the user based on its pattern. We analyze the data, existing data in the system, and based on that, we recommend the new components which can be placed in the network, and we learn from it. So based on that learning, it helps human in the next time whenever they design a new system.
Thank you so much. With this, we come to the end of today's webinar. Thank you all for joining us. We hope you found the session useful. And thank you, Vipin and Lakshay, for sharing your valuable insights. If any questions remain unanswered, our team will follow up offline. If you'd like to explore how Amantya can support your GIS platform modernization or AI initiatives, we'd be happy to arrange a one-on-one discussion. You can also reach us at connect@amantyatech.com or through the contact details that will be shared along with the webinar recording. Thank you once again for joining us today, and we look forward to seeing you in our future sessions. Bye-bye.